Today we'll discuss Epsilon NFA to DFA. For this method, we must know that the E-closure of a given automata or Epsilon NFA. Okay. E-closure of all the state. So how we can calculate this E-closure is what are all the empty moves from all the state. That is only we are going to calculate in this function. So for example, I have one Epsilon NFA. Okay. So this is the empty string, empty string, empty string. This is also empty string. This is empty. This is empty. This is E, and this one is another input string. Okay, this is my diagram. This diagram we know that this is epsilon NFA. Now I want to calculate E closure of all the state. So it started with E closure of 1. Okay. So how we can solve this? First one is whatever state you want to calculate the E-closure function, first include that state. So first I'll include 1. Next you can go to the diagram. From 1, what are all the empty moves that you can include? The empty move from 1 is 2 and 4. Okay, that you can include. First you can include 2. Finally we can check out from 2 what are all the empty moves. From 2 I have a again move is A, that you can include 3. From 3, I have a move is 6. From 6, I have a 8. Almost this path is over, right? Like that, one more path is also we have. So 1 to 4 is also empty string. Include that also. From 4, there is no empty move. You can stop the process here. So that you can rearrange also. So the value for one closure of E closure of 1 is 1, 2, 3, 4, 6, 8. That's it. Like that, for E closure of 2 is equal to first include 2. From 2, what are all the empty moves we are having? First 2 to 3 is an empty move. Then include 3. 3 is also you have an empty move. 6. 6 is also you have an empty move. 8. That's it. There is no empty move from 8. You can stop here. E closure of 3. That is equal to first include 3. Then check the diagram. 3 to 6 and 6 to 8. So we have 6 and 8. Okay. Like that, E closure of 4. First include 4. From 4, there is no empty move, right? You can stop the process here. So E closure of 4 is 4 alone. I want E closure of 5. First include 5. From 5, I have one empty move, right? 7. From 7, there is no empty move. So 5, 7 is E closure of 5. Then E closure of 6. First include 6. From 6, I have an empty move. So 8 is also we can include. And E closure of 7, actually only 7, there is no empty move. Finally, E closure of 8, only 8. That's it. This is E closure of all this state. Like that only how to calculate. For this problem also, we are using this function. For removing all the empty symbols, then only I can get DFA. Okay, you see one method, one problem related to epsilon NFA to DFA. For example, So I have a diagram is from Q0 to Q1. Q1 is a final state. So this is, I'm using 0. This is empty string. This is, I'm using 1. Okay. First, you calculate E closure of these two states. So E closure of 0 is, Q0 is first Q0 and empty move is there from Q0. So Q1 also you can include. E closure of Q1 is, I think, only that state, right? Q1 alone. First, you can complete this E closure. Next, we'll move on to the first step of this problem is you have to calculate the initial state. So initial state, how we can calculate is E closure of initial state of for Epsilon NFA. So E closure of initial state of Epsilon NFA is Q0, right? So that you can take it. So already E closure of Q0 we calculated, right? What is the output? Q0, Q1. That you can take it. This is a one new state. From the state only how to start our transition mapping. Okay. NFA to DFA also we start from initial state. No, here is directly we start the problem, right? Transition mapping. Here is you calculate the E closure of Q0. That state you have to start. This is only the initial state of a DFA. Now, directly I'll move to the next is a transition mapping. So transition DFA off. This is a state. This is only initial state that I have to start it. So Q0, Q1, comma, input symbol is without empty string balance you can consider. So 0 and 1. So I'll start 0. The input of this method is Epsilon NFA, right? So this is considered as a single state in DFA. But if you are considering Epsilon NFA, this will be considered as a two different state. Two different state means use a union symbol. So transition E meaning is Epsilon NFA. So Q0 comma 0 union transition E Q1 comma 0. Okay. Q0 comma 0 is the output is Q0 only. Union Q1 comma 0 is null value. Okay. After calculation of this function, how to apply E closure of this state. Okay. So this is equal to E closure of Q0. Actually, already we completed, right? The output is Q0, Q1. That you can write here. So one input symbol is over. Like that, you take a next transition mapping Q0, Q1, 1. That is equal to. Okay, transition. This is also more than one state. So use a union symbol Q0, comma 1, union, transition E, Q1, comma 1. So this is equal to Q0, comma 1 is there is no value. So you can put it as null value. And Q1, comma 1 is we have a value is Q1. So output is Q1. Apply E closure of this Q1. So E closure of Q1 is equal to Q1. Okay, we completed the initial state zeros and ones transition mapping. So this state is already we completed, right? Q0, Q1. Q1 is a new state that I have to start. That I have to calculate the transition mapping. This is same as a NFA to DFA. So now we can start from Q1. So transition. Transition DFA of next state is Q1, right? So Q1 comma 0, this is equal to transition Epsilon NFA of Q1 comma 0. So the answer is actually Q1 comma 0 is null value. And one more thing also I have to calculate, one more input symbol, right? Q1 comma 1. So this is equal to transition Epsilon NFA of Q1 comma 1. So this is equal to Q1 only. So after this is apply E closure of Q1. E closure of Q1 is equal to Q1. That's it. Okay. Is it clear? So it's very simple. Start from that Q naught initial state, apply the transition function. This is same as NFA to DFA. Only difference is after calculation of a transition mapping, use this E-closure also. If you're having new state, you have to do this process repeatedly. There is no new state, you can stop this transition function. Now we completed this Q naught Q1 and Q1 is also completed. That's it. We can close it. Now the transition mapping is over. Only two state we calculated, right? So next, third input symbol of this problem is, you can take it as an input symbol. So input symbol of DFA is 0, 1. Fourth attribute is initial state. Initial state is calculated, right? Transition mapping, set of states, we can take it. Set of status, actually one is your initial status Q0, Q1. And one more status Q1 alone, right? Only two state we calculated transition mapping. So that alone you can take. Final status, what is the final state of for Epsilon NFA is Q1. So here, wherever Q1 is it, that will be called as a final state. Both places I have a Q1. So both state is a final state. Q0, Q1 is one final state and Q1 is another final state. That's it. You have to draw the diagram for this transition mapping also. So I'll tell you that alone. I'll start with initial state. Initial status Q0, Q1. But this is the initial state and this is a final state also, right? So I'll put it as a double circle. Q0, Q0, Q1, 0 is where it is going, Q0, Q1 only. So I'll give it as a self loop. This is 0. Q0, Q1, 1 is it is going Q1, right? So from here to Q1 is a final state. I'll consider as a double circle. So this is 1. Q1, 0 is null value, right? There is no value. Q1, 1 is Q1 only. So I'll give a self loop. That's it. This is DFA. Epsilon NFA to DFA. This diagram is DFA. Thank you.